in the last lecture we have learned how to calculate the absolute error, the relative error, and the percentage error. And in this lecture we shall learn about the combination of errors, how to calculate the combination of errors. The first type of combination is a sum or a difference. So we have the first combination. This is when you take the sum of or a difference of two or more physical quantities. Sum or difference of the physical quantities. So this is the first type of combination. Now, for example, if we have here quantity 1, okay, physical quantity 1, and this is say measured as A plus minus delta A. And if we have another quantity 2, any quantity 2, this is the second quantity, and this has a measured value of say B plus minus delta B. Now whenever you see this type of expression, A plus minus delta A, B plus minus delta B, now this we have learned, we have come across this one delta A. What is this one? This is known as the absolute error in the measurement. Now this quantity here, this expression here A, this is known as the true value of the measured quantity. So this is the true value of the measured quantity 1, and this one B is the true value of the measured quantity number 2. Okay, so here this one, this expression here, this is known as the true value, and we have also learned how to calculate the true value in the last lecture video. And these here, they are known as the absolute error. Absolute error. Okay, so we have two quantities here, 1 and 2. The measured value of quantity 1 is A plus minus delta A, and that of quantity 2 is B plus minus delta B. Now if we have to take the sum or the difference of these two quantities, then we'll also have to calculate their absolute error. For example, if you add quantity 1 and 2, so if we add these two quantities, say Q1 plus Q2, then the addition or the sum of these two quantities Q1 plus Q2, this can be expressed by summing the true values and also calculating the absolute error. So in this case, if we have to add the two quantity, this will be expressed as, you add the two values A plus B, this will be the true value of the sum. Then also for this absolute error, in this case what you have to do is you'll have to add the two absolute error also. So delta A plus delta B. So the sum of the two quantity Q1 and Q2 is expressed as A plus B, adding the two quantities true value A plus B plus minus, then adding the two absolute error delta A plus delta B. Now if we have to take the difference also, so if you have a Q1 minus Q2, then this difference is expressed as, here we'll have to take the difference of the true value A minus B. So Q1 minus Q2 is expressed as A minus B, then plus minus. Now you'll say that in this difference, we'll have to take the difference of this delta A by B, but that's not the case. Even when you take the difference of the two quantity Q1, sorry, I'll just Q1 and Q2, if you take the difference Q1 minus Q2, for the absolute error you'll always have to add. So in this case, it will be delta A plus delta B. Okay, so in both the sum and the difference, you can see the absolute error is found by adding the absolute error of the two quantities. Okay, except for the true value, you'll have to take the difference, but for the absolute error, you'll always have to add the absolute error of the two quantities. Okay, it doesn't matter if it's plus minus. Here it should always be plus, and here depends. If you take the sum, it's plus. If you take the difference, it will be minus. So that is one way of finding the error when you combine two quantities. That is by summing the two quantities or by taking the difference. Alright, so if we have this example, the temperature of two bodies are being measured by a thermometer, and they are found out to be the body number 1, T1, is equal to 20 degrees Celsius plus minus 0.5 degree Celsius, and that of body 2 is T2 and is equal to 50 degrees Celsius plus minus 0.5 degree Celsius. Now calculate the temperature difference and the error therein. So here we have two physical quantities, that is two bodies, and the temperature of these two bodies is given to be the first body T1. This is given to be 20 degrees Celsius plus minus 0.5 degree Celsius, and that of body 2, the temperature of body 2 is equal to 50 degree Celsius, then plus minus again 0.5 degree Celsius. So as I've told you earlier, if we have to take the difference, then we'll have to subtract these two true values, and this one here is the absolute error. Alright, and here we'll have to sum these absolute error. So if we have to take the difference of the two bodies, that is say T dash, then this will be equal to T2 minus T1. So what how will you express this one? You take the difference of the true value of this T2 and T1. So 50 degrees Celsius, I forgot to write that one. So 50 degrees Celsius minus 20 degree Celsius. So that is the true value. So you have to take the difference of the true value, then plus minus. Now for the absolute error, you'll always have to add. So here we have the absolute error 0.5 degrees Celsius, here also 0.5 degrees Celsius. So what you have to do here is, you'll have to add the two at a 0.5 degrees Celsius plus, I'll continue it here, 0.5 degrees Celsius, then we have plus this one also 0.5 degree Celsius, so 0.5 degree Celsius. So this T dash, this will be equal to 50 minus 20, that will give you 30 degree Celsius, then plus minus, what is the absolute error? 0.5 plus 0.5, and that will give you 1 degree Celsius. So this is the expression for the difference of the temperature of the two bodies. It is equal to 30 degrees Celsius with an accuracy of 1 degree Celsius. Okay, so remember, this is the true value, and this is the absolute error of the combination, that is the difference of the two quantities, the temperature of the two bodies. Now the next type of combination is the product or quotient of any two quantities. For example, quantity 1, the measured value of this quantity 1 again says A plus delta A, and the measured value of the quantity 2 is B plus delta B. And now if we have to take the product or a quotient of the two quantities, then what will be the error? So here we have the absolute error for this quantity 1 is delta A, and the absolute error for the quantity 2 is delta B. Now in this case, in the case of product and quotient, we'll have to take the relative error. We cannot take the absolute, just the absolute error, not like in the earlier cases, we just take the sum of delta A and delta B. But in the product and quotient, we'll have to take the relative error of both these two quantities, Q1 and Q2. Then only we'll sum that error. So for example, what is the relative error of this quantity Q1? We know that this is the true value and this is the absolute error. So the relative error for quantity 1 is, so for Q1, sorry, the relative error this will be equal to the absolute error divided by the true value. So here this is the true value, absolute error, so the relative error will be delta A divided by A. Now if we have forgotten this formula, you again revise the earlier lecture which I've given you in how to calculate the relative error. Now for quantity 2, the relative error this will be equal to again absolute error divided by the true value. So if we have to multiply the two values here, then the relative error of the product or the quotient will be given as delta Z by Z. Alright, and this will be equal to the sum delta A by A plus the sum of delta B by B. So this is the relative error of the combination of two quantities when you multiply or you divide the two quantities. Okay, if you take the product or if you take the quotient, then the relative error of that final quantity, which is Z here, will be equal to delta A by A plus delta B by B. Yes, for example, if we have a circuit here, I don't know if you have seen the circuit, I think you have done this in class 10. So this is a battery and this is a resistor, and current is flowing through this circuit, and that current is I. And say we have a voltmeter, or we want to calculate the voltage across this resistor of resistance R. Then if we have measured the voltage as V is equal to 100 plus minus 5 volts. So this is the voltage across the resistance R. It is measured as 100 plus minus 5 volts, and the current is also measured as 10 plus minus 0.2 ampere. So we have these two values here, two quantities, voltage and the current. Now if you want to find the resistance, then you have to use Ohm's law. And Ohm's law, what is the formula of Ohm's law? your V will be equal to I into R. So this is Ohm's law, and R here will be equal to V divided by I. So here you can see this is a quotient. Okay, so you're dividing this quantity by this quantity. You're dividing voltage by current to get the resistance. So here the question is to find the percentage error in calculating this resistance R. So what we'll have to do is that we'll have to first find the relative error of the two quantities. If we want to find this percentage error in calculating R, we'll have to find the relative error in calculating R. So what is your delta or your relative error for V? So for the first quantity, for V, relative error this is equal to, what is the absolute error here? 5. What is the true value? 100. So I'll drop this one off. So we have 5 divided by 100. This is the relative error for V. Then for I, what will be the relative error? Relative error for I, this will be absolute error 0.2 divided by the true value for I. So this is 10. Now this is the absolute, the relative error for V and for I. Now if you want to find the percentage error, what should you do? If you do not remember, you again revise from the earlier lecture I've given you. To find the percentage error, you'll have to multiply this relative error with 100. So here, for V, the percentage error, I'll drop this one off. The percentage error for V will be, you multiply this with 100. And the percentage error for I, you multiply this with 100. So this cancel, and this 100 and this 100 cancel. So what you get here is only 5%. And what you get here is 2%. Okay, so here if you want to find the percentage error, the combination of this in R, okay, so percentage error in R, so I'll write here for R, the percentage error. Now I'll just write first the formula. First you need to find the relative error in R, and that can be found by using the earlier formula. So delta V by V plus delta I by I. This is the absolute, the relative error in R. The percentage error can be found by multiplying this with 100. Okay, and if you have multiplied this with 100, you'll get for V 5%, and for this delta I you'll get 2%. So the percentage error for R, this will be equal to delta V by V into 100% plus delta I by I into 100%. So this one is how much? 5%. This one is how much? 2%. So what we have here is 5% plus 2%, and this will be equal to 7%. So that is the percentage error in measuring the resistance R, which is here 7%. So first you have to find the relative error of V and I, then calculate the percentage error, then you sum the percentage error, 5 plus 2. If you're asked to find just the relative error, then find the relative error for V, find the relative error for I, then the relative for R will be the sum of the relative error of V and I. Okay, so that is the second type of combination in product or quotient. Okay, so this is the quotient, and similarly for the product also of any two quantity, you'll have to sum the relative error of the two quantities, or if you ask to calculate the percentage error, you'll have to sum the percentage error of the two quantities. Now the next combination is when a measured quantity is raised to a power. For example, if we have a square, so this is a square. Now the sides of the square, they are all equal. Say this is A, right? Then this is A, this is A, and this side is A. So side A. So this is a square. Now what is the area of a square? The area of a square is found out by multiplying the two sides, any two sides, A into A. So here what we have, say Z is the area, and this is equal to A square. Now if there is some error in measuring this side, then there will be an error in measuring the area also. So to find that one, we'll have to calculate the relative error or the percentage error. Now we have done the product, error in the product, right? So this can be written as A into A. So how will we find the relative error in measuring the product of a quantity, the product of two quantity? The relative error in measuring the product will be given as delta A by A plus delta A. You will always have to add the relative error of the individual quantity that we have done in the previous topic. So here we have 2 delta A by A, and this will be equal to twice delta A by A. So the relative error in measuring this quantity here, the area of a square, is 2 delta A by A. So you can see here this 2 appears here. Alright, so in the quantity raised to a power, you can see this one A is raised to a power of 2. What will be the relative error? 2 delta A by A. So whenever you have a quantity which is raised to a power, this 2 will always have to come here. If it's 3, there will be 3. If it's 4, it will be 4 here. Okay, so if you want to measure the relative error of any quantity which is raised to a power, then this is the formula. Whatever you see here in the power, you'll have to multiply it to the relative error of that quantity. Right, so again we take say another example. We have a quantity so we have a quantity Z, and this is equal to say A to the power of any number of variable P. And P can be 1, 2, 3, 4, any values, and then B to the power Q, and then Q also can be 1, 2, 3, any, or it can also be a fraction, then divided by, now you see the quotient here, C. Then the relative error in this delta, in measuring this quantity Z, right here, relative error for delta Z by Z, this will be equal to, now for this A, you have this A raised to a power P. So the relative error for this A will be P, raised to the power P will be P delta A by A. Then we have to sum to this one, because this is a product. Whenever we have a product or a quotient, we always have to sum. So here we have another quantity B. So this is raised to a power Q. So the relative error for this BQ will be Q into delta B by B. Then here we have quotient. Again, whenever you have product or quotient, you always have to sum the relative error. So here we have C, and this is actually raised to a power 1. If there's nothing here, it means C to the power 1. So here we have 1, or I just ignore that one. So 1 delta C by C. So this is the relative error in measuring the quantity Z. So delta Z by Z is equal to P. This P comes here, delta A by A, then plus this Q comes here, then delta B by B, plus this one comes here, delta C by C. For example, say a physical quantity P is given by the relation P is equal to A to the power 3, B to the power 2, then divided by root over C into D. The percentage errors in measurement in the A, B, C and D are 1, 3, 4 and 2% respectively. So the percentage error in A is 1%, in B is 3%, in C is 4%, and in D is 2% respectively. The question is, what is the percentage error in the quantity P? So here your P is given. This will be the solution. P, I'll let this one off. So here your P, this is equal to A to the power 3, B to the power 2, then divided by root C into D. And percentage error in A, B, C and D is given. What you'll have to find is percentage error in P. Now whenever you have to find percentage error, first you'll have to calculate the relative error. Now we know how to calculate or find out the relative error in P, that is delta P by P. This is the relative error in P. So this will be equal to, now here we have A is raised to the power 3, so this will be 3. Relative error of A is delta A by A. Then sum, because it's a product, so you have sum. Then B is raised to the power 2, so here we have 2 delta B by B. Then quotient, then again also this is quotient, you have to sum. Then here you can say C. Now this C, you know from maths, root C, this is equal to C to the power half. Okay, so this C is raised to a power half. So here instead of this, you'll have half delta C by C. Then again you have product, which is again you have to sum. Now D, this is raised to the power 1, so we have 1 here, which I will not write, delta D by D. So this is the relative error in the measuring the quantity P. Now to find the percentage error, what you have to do is you'll have to multiply this with 100. This will give you the percentage error in the quantity P. So here, if you multiply this with 100, here also you have to multiply 100, 100, 100, 100. So here we have 3 delta A by A into 100. Then this quantity in bracket will give you the percentage error in measuring this A. Then plus we have 2. Then there also you'll have to multiply it with 100 to get the percentage error in B. this quantity in bracket again is percentage error in B, then plus we have that one half, then we have delta C by C, then here also into 100. This will be the percentage error in C, then plus and delta D by D into 100, then this will be the percentage error in D. So remember what you asked, to find the percentage error in the quantity P. So that will be equal to 3. Now in the question, what is the percentage error in A? The percentage error in A is given to be 1%. So this will be equal to 1%. What is the error, percentage error in B in the question? It's 3%. So this will be 2. This is the percentage error in B, which is given in the question to be 3%. Then what is the percentage error in C? In the question it's 4%. So this one is 4%. So I'll write it here, plus half into 4%. Then plus, what about this one D here? In the question it's given to be 2%. So this simply is 2%. So this one is 1%. Again, I'll write it here. So this is 1%. This one is 3%. So into 3%. This one is 4%. So into 4%. And this one is 2%. Simply plus 2%. So here 2 and this one cancel. This 4 here, 2. So here we have 3 into 1, which is 3%, plus 2 into 3, this will give you 6%, and this will be 2%, this will be 2%. So if we add 3, 6, 2 and 2, you'll get 13%. So that is the percentage error in the quantity P. So we have learned 3 combinations of error. The first combination will only have to take the sum of the absolute error of the two quantities. So the first one is sum or difference. Here the first one will have to take just the sum of the absolute error of the two quantities. Then the second one is the relative error. When it comes to product or quotient, we'll have to take the relative error, sum of the relative error. This is for product or quotient. Then when it is raised to the power, to some power, when your quantity is raised to some power, then again we have to apply this one only, but you see whether the quantity is raised to some power. If they are raised to some power, then you'll have to multiply this with the power which the quantity is being raised. Here also you have to multiply it with the power in which the quantity B is being raised. That's the only difference. Then with this relative error, we can also calculate the percentage error. Okay, I'll write it here. So we can also calculate the percentage error as delta A. We have found out the relative error, we just multiply this with 100. Then you multiply this 100, you'll get the percentage error.